See who's in the room so far. Oh, damn. Okay, we got a lot of people. How you guys doing? Good, I hope. Today we're gonna be covering uh, badges, some other tools, Flipper Zero, and I'm a little low. Is this better? Hold it up here. I'll hold it up here. All right. I hope it's not too loud for you guys. Yeah, it's in the yellow here, so I think I should be good. See, we're doing hardware badges, multimeters, other things. We have a bunch of tools out. We have a bunch of the badges from DEF CON out here right now. Bunch of tools, the Flipper Zero, multimeter. So we actually have two presentations today. One is just a brief introduction to a bunch of tools. Another one goes in a little more detail on these. So we'll be doing both of those. It's more like circuitry and electrical stuff. So people, if you're doing like networking or like advanced networking stuff, this is a good presentation for you. But Flipper Zero is definitely a great multi-tool. We will be starting momentarily. All right, I gotta keep talking. So, um, hardware badges, multimeters, and other shenanigans. So, remember, guys, I believe next week is the DC 702.
You hear yourself at all?
Mm-hmm.
Yeah?
I hear myself.
Okay, I'll turn it down a
Is
little
next week the DC 702?
bit. Yes.
All right, next week, you guys would want to come out. DC 702, the local cybersecurity hacking group, is going to be here. They're going to bring a bunch of stuff for us to see, do a presentation. And it's also Lily's birthday, Professor Lily. So we will be celebrating that. So we will have club a little early that day if you want to come, hang out, and celebrate the birthday. Then we will be doing our DC 702 stuff, and that will be the day. But yeah, it's definitely one you want to come out there. They're a local group. They do meetings every Wednesday. They work with SynShop a lot. A lot of people are knowledgeable on different things, so it's a good place to network if you have a project you need help on.
All right.
All right. So, hope everyone's doing good today. Today we're going to be doing some multimeters, some I already told you guys on stream, trinkets, tools. Um, and really quick, if you guys haven't yet, let us know if you haven't activated your Try Hack Me Premium, because every person in this club can get a free Try Hack Me Premium account. Really useful, not only for hacking but learning networking basics, learning basics of different things. You can learn a lot of like OSINT, just other things that aren't especially related to hacking, but great resource to use, and it looks good on your resume that you're going out of school and doing extra stuff to keep yourself ahead, because the IT industry is always changing. So disclaimer: we do not condone breaking the law. We do not come here looking for ways to break the law. We are here to help each other learn, and this is strictly for educational purposes, to develop yourself, develop your knowledge, work on projects, whatever that may be. But yeah, this is educational. Don't commit crime. We are not liable. All right, so here we have isn't that? Hold on, I gotta. There we go. Meet the multimeter. So the multimeter measures two or more electrical values. So it measures volts, amps, and resistance, or ohms. And its tool is useful for networks. It's useful for testing. If there's a short, testing different electrical properties of your network. I know have not had any experience with one, but the next presentation we're going to see should have more information on multimeters. But it is more of an electrical tool that you will see. A lot of network admins may use it to test different parts of the network if there is an outage. All right, now we have the badge. Meet the badge. Badges range from useful gadgets to hacking tools to fun trinkets. As you can see, a lot of these look really cool. They're designed to be really cool and look fun. Stuff that you can like display. DEF CON gives out badges to people who attend the event every year. So one of the cool ones I like is a little piano. It's a badge, which is a piano. And a lot of these badges comes with challenges to solve, where you connect the badge to your PC or someone else's badge or a modem. So a lot of the badges, more than meets the eye. It's not like a flashy, light up little trinket, but usually they can have like scripts in them. They can have challenges to do. A lot of fun stuff can be done with the badge. You can even upload your own stuff to the badge. Meet the Flipper Zero. I'm sure you guys have already known about the Flipper Zero before this, but it's a very popular tool right now. It's a multi-tool that has many functions displayed on a little GUI. It contains radio transceivers, RFID scanners, NFC capabilities, Bluetooth, infrared transceiver, micro SD card slot, one-wire key scanning, changeability where you can open it up and you can change parts on it if you want. You can mess with it in so many different ways. It's such a versatile tool. Definitely something to check out if you are serious about pen testing and want to try more of that. It's has a lot of capabilities. It can even be a bad USB. It's really like people say it's one of the best multi-tools to try right now because just how much stuff you can do with it. They're about $150 on the Flipper Zero website if you guys are looking for them. I think they're sold out right now, but definitely check out the Flipper Zero website. They go back in stock frequently. Definitely a really cool and crazy tool to use. The Crypto Corner. It will be posted later. It's not displayed here yet, but we'll post it later in the Discord because I couldn't upload this. But we will have the Crypto Corner later, so be sure to answer that and you can win a goodie. Thank you guys, and we will be moving on to our next presentation shortly.
Okay, my name is Jason. I'm actually an electronics technology student or engineering technology student. A lot of the stuff we cover in the Cybersecurity Club is way outside of anything I know. I took Linux and Network Plus and heard about the club, so here I am. Everything I'm talking about today is well outside of what you guys are going to ever need to know for cybersecurity, unless you want to get into hardware hacking. So if we can go to the next slide. So fundamentals of electronics is what we're covering. Voltage is the difference in electric potential between 2 points in a circuit. So if I have a voltage coming in here and I want to test this resistor to find out how much voltage is there, this side's going to have more, this side's going to have less. So when we're using a voltmeter, you're going to connect the probes across a component and find out what the difference is between those two sides, right? And obviously it's measured in volts. Current is the rate of flow of electrons through a conductor, such as a wire. What we're doing is we're looking at one specific spot, like right here, and I'm seeing how many electrons flow past that point in a second, and that's how I get current. And it's measured in amps. You'll always see A, or more commonly milliamps in electronics. If you have amps coming through electronics, that's a lot. Resistance is the measure of the opposition of current from a device, such as a resistor. So I know how much voltage is going across. The voltmeter will measure that, and then it'll tell me how much this device is resisting the flow of that voltage and current. And it reads it out on the display for you. And it's measured in ohms. Typically, you're going to see things that are anywhere from 100 ohms or 220 ohms all the way up to sometimes 200,000 ohms or 400,000 ohms, depending on how much current you're trying to resist. So there's two basic types of circuits. There are series circuits, which it's a circuit that comprises of a path along which the whole entire current being put in will flow through each component one to the next. So you can follow those arrows around and see that it starts at that battery or that voltage source. That layer of lines is a battery. Yep. And then it goes through each component back into the end, which is the negative side of the battery. And then in parallel, it has two or more branches creating multiple paths for the current to flow through. In series, each resistor is dropping the voltage one after the other. In parallel, that current is going through each one. They each have the same voltage, but the current gets smaller in each of the resistors and then returns coming back to the battery. Now is more of what I wanted to kind of cover with you guys as far as what you're going to see on proto boards or printed circuit boards. Common components. So resistors, you'll see the ones up top, and then the ones on the bottom. The ones on the bottom are called surface mount, and the ones on the top are called through hole. I have boards that have both on there. Resistors are used to control current and voltage and make them smaller or larger depending on how you have them configured and what you want to go into a chip at different places to get a different signal. Capacitors are used to filter. Most commonly we use it to filter out DC from an AC signal. So you have a data signal that's going into a component or into a circuit. There might be some DC voltage on it, which is what we call noise, and you don't want it in there. Like if you're trying to read something like someone's RFID chip, it's going to have a capacitor filter in there to remove any extra noise that's around. And we do that through capacitors. They'll also only allow voltage to go back and forth if it can do so. Whereas if we have DC, which I forgot to talk about, it won't let DC through. So DC voltage only goes in one direction. Alternating current, which is what's in your walls, goes two directions. It goes back and forth, right? And it's a sine wave. Whereas DC only goes in one direction. Inductors are used to control current. You have this coil that's around an iron core, and it stores current or it stores a voltage in those coils. You have this magnetic cloud that all this energy is sitting inside of. And so when the current starts going downstream, like starts slowing down for whatever reason, that inductor will then allow more current out. But on the flip side, it will only allow a certain amount out, right? So we rate our inductors to allow a certain current through. So you won't get more and you won't get, and if it starts going down, that inductor is going to help keep that current flow steady for your device. Diodes only allow current to go in one direction. So you have this arrow, the direction it's pointing is the only direction it's going to allow current to flow through. It can be used for many different applications. Go to the next slide, please. Diodes are the fundamental concept I'm studying this semester in solid-state electronics. They're also what make up what's called transistors. You're probably more familiar with transistors and seeing them on boards. They're used all the time. They're used in amplifiers. So if you've used a stereo, you've used a transistor to get different frequencies on the output, as well as you've taken this tiny little signal that's come in on the airwaves, and your radio boosts it through using transistors as amplifiers to make that signal bigger. And finally, microchips and integrated circuits. Integrated circuits are very particular in what they do as far as what's called logic. So you guys are all familiar with 1's and 0's. That's data. Integrated circuits on the inside, so you have this one up here on the left. That's called a 7486 chip. And this is what it looks like on the inside, fundamentally. It's a lot more complicated than that. It's called an XOR chip. We have XORs and XANs that are used to fundamentally make up these more complex chips that you guys know as microchips, like your microprocessor chips or your flash ROM chips. Those are made up of trillions and millions of these tiny little gates that do specific things. They will add, they will subtract, and do all kinds of mathematics for you, millions of computations per second, right? And that's all done through all these other components that we've talked about. They've condensed millions of those inside of a tiny little chip that you see up on the right. And the main purpose of all of this is to get to talking about what's called the digital multimeter. It's our most fundamental tool. Any electrical technician or electrical engineer, if you asked them, if you were to be stuck on an island where you had to just do electronics, what would you take as your one tool? It's going to be this multimeter. Oscilloscopes, I can see waves and what they're doing, and I can see logic on them, but I can also fundamentally do it with one of these. And it's a lot more simple. So some of the functions you'll see, you have a voltmeter, an ohmmeter, and an ammeter, right? Each of those do their particular functions. Voltmeter tells you voltage, an ammeter tells you current. So a voltmeter you test in what's called parallel to your component. So I want to see what voltage is on my resistor right here. I'm going to take one probe, the positive, and put it on the positive side of the circuit, and then I'm going to, which is the red, and I'm going to take the black one and put it on the left side or the negative, or on the right side, and it'll read. That's called parallel, because you're reading parallel to the resistor. Yes, Brandon?
You get a multimeter for the laptop if you want to. It's by your laptop on the desk.
Thanks. So you have two different voltages you can read on here. So you guys can't really see it because this is tiny, but you have an AC symbol. That's going to read only alternating current. Then if you want to read, which is going to be like what's coming out of your wall. And on some of your circuits, you'll have AC voltage. DC voltage is what is in batteries, which is also represented by the dotted or solid line on a voltmeter. And then on this one, we next have an ohmmeter, which is how we test resistance. So real quick. So resistance you also test in parallel with your voltage. And then with current, you want to test in what's called series. You never test in parallel because it will fry your meter, and then you have to go out and spend $10 on a fuse because you've fried it. So if I want to test it, I will go from my voltage source to my component. I will actually break a gap in between here and test what current is flowing between those 2 points. And when you're testing boards to repair them or find out more of what's going on, the two most important modes is diode mode and what's called continuity. So diode mode, I'm going to test a component in both directions. So red on one side first and then red on the other, right? And I'll flip. And that tells me which way the diode functions. Continuity, anywhere on the circuit that you can find ground, it'll be GND. Some of them are a little easier to find. And then the component you're testing, you'll want to put the red or the positive side of the multimeter on, and it tells you, is there current flowing through this? Next slide. That's all to find two faults. One is called a short circuit, which is a low resistance connection between two conductor points. Your component that was supposed to function like a resistor or a capacitor or some other device, your chip even, your fancy IC chips in your iPhones, will suddenly, for whatever reason known to the gods, it's now acting like a wire and not functioning as it was supposed to. Some connections melted inside of it. It now just acts like a wire, which will often lead to component burnout or sometimes, if you're lucky, fires. Also, you may have opens, which is a path in a circuit that has been separated and current can no longer flow through the device. It also shows on an ohmmeter as OL, which is, oh God, I don't remember now. We just call it an open on the multimeters. You'll see OL. And then if you see out of range, that also means that it's an infinite resistance. And I think that's it, yeah? Oh, okay, data sheets. So these are our second best friend next to a multimeter. You can find and look on a component most of the time, unless it's been erased, find out what the name of it is. So I just randomly searched a flash ROM chip and came up with the STM8L051F3. That will likely be printed on the chip. These tell us everything about the chip. This is our fundamental building block of what we do on the electronic side. I look at a board. If I don't know what the device does, I look it up in a data sheet and learn about it and how it functions.
In terms of cybersecurity, because we are a cybersecurity club, the reason why we're looking at this stuff, guys, is because we play with a lot of hardware. And in cybersecurity, this specific point, which is the data sheets, this right here is where you would look to see information about a device and the components on it. Like he said, in terms of cybersecurity, right, you can look this stuff up and you can find out, is there a common vulnerability with this device or this component? Is there something out there that has been documented already, a known issue with this stuff? We have hardware badges to play with, and you get those from conventions, but in terms of cybersecurity, that's why you want to know this kind of stuff. You're playing with hardware all the time. You're on a computer, for Christ's sake. You know, like there's a lot to know. So that's why we're talking about this stuff.
Next slide, Brandon. So the most important, besides kind of the fundamentals of what that chip does or what that component does, is this, the pinout. So hardware hacking, you're going to take devices like a bus pirate. You're going to have to connect it to very specific pins and then get it to print out using like a Linux terminal. You can give it a command and then it will feed out certain information. Like your flash ROM will now dump everything that's on it given a certain command. But you have to know the pinouts that you need to connect the probes to, because if you do it wrong, it's not going to give you what you want. Or if you connect your device to the right here where it says VSS or VSS reference, positive and negative, that's your power and ground. If you took your device and connected it to there, it may short your bus pirate or whatever device you're using. So you have to know very specifically how to connect to it in order for your hacking device to work. So that's all I have. So yeah, data sheets and multimeters are probably your best friends in hardware hacking, because it's going to tell you what the device does, and then you can use a multimeter to test if it's functioning properly, that circuit as a whole, or you can find out where you need to connect your certain pins in order to get the information you want. So, is there any questions? Wow.
Can we apply these topics to digital forensics and apply it like other degrees as well, like other
Absolutely. Absolutely. There's a couple of people I watch on YouTube more recently because of this club. I've learned about hardware hacking and looked up what those ladies and gentlemen do. One lady, her shop is called iPad Repair. She takes iDevices and fixes them in order to get people's data recovered from those devices. Your screen is cracked, you got smashed by a car. There's a small chance she may be able to take the chips off of your phone or connect them and put in components that are working in order to save all the valuable data you had. Then another gentleman, I don't remember his channel, he was an electrical engineer, got into cybersecurity, was teaching at a university and started getting bored. But then people came to him and said, hey, you know a little bit about hacking, and I have this Bitcoin wallet that has millions of dollars on it, and I need to get into it. Joe Grand, yes. So he uses the fundamentals of this technology, and he does hours and hours of research learning about how the chips work, how all these components work, what do I need to short on this capacitor or these different components to get this thing to link up with my Linux script that I'm telling it to short itself out in order to let me into the information. So yes, there's a lot of stuff that you want to know this if you want to get into hardware hacking or data recovery, and as well as forensics. Because some people, when you show up to their house to collect their devices, they're going to smash it, throw it through a magnet, whatever. And you having the fundamental knowledge of how electronics work, you can work with the software people as well, and as a team, recover that data for whatever purpose it is needed. So,
Okay, so instead of recovering data, what about blowing out circuits and resistors and all that?
absolutely. So there's I'm going to throw another name out there, Jacker Sider. Lily's a big fan of him as well. It's a podcast on YouTube. He's mostly hacking stories. But he talked about a story in which, what are those called? Reporters. Reporters have been receiving devices such as little flash drives that someone is rigged with some sort of explosive. And then when it is plugged in and receives a power source, it will explode, not only damaging the device, but also potentially damaging that reporter. So that's another application that's been used by black hats as well. So, yeah.
I have a suggestion for you when you go home.
Okay.
You're going to want to look up exploding USB O.mg.
Exploding USB.omg.
O.mg.
O.mg. Okay.
You guys are in front of computers. Look it up now.
So, any other questions?
Cable that I used to, an OMG cable that I used to know about, something like that.
Same guy.
I don't know if that's the same guy.
So,
I
yeah.
have one more question.
Yes, sir.
Do we have stuff for people to play with here right now and try to mess with?
We do have multiple badges and boards if you guys want to test components or learn how to use a voltmeter. We have them here on this bench. I have a couple of boards that I've provided that if you guys want to talk about soldering or learn a little bit about soldering, we can do that as well. So feel free, pick up the boards. If you want to ask questions, I can try to answer some of it, but otherwise, feel free to play around with the boards. And thank you guys for those of you that are online for joining us. Hope you have a great evening.